There's still a few more things I have to let you know that you have to be able to do to make sure that you be prepared for the final. Start with the projection. And this is the formula that you have to remember, and it's not on the cheat sheet. Okay. But it's not as bad as it seems, because if you do it for a few times, you'll be able to write it down, right? But the catches are, if its projection of B onto the W, you have a whole bunch of W's, right? And the V goes first. And there is a square there, right? And you will see options that they know that people's going to forget about a square, and there will be a answer choice without a square. Also, we did the calculation, right? We see that it's not really that bad to calculate this kind of projection vector onto the W. Okay. And let's do it one more time. And also, let's take a look at maybe some subtlety in case we run into issues like that. Now, projection of V onto the W. Right, it is the V dot in the W divided by the W magnitude square, and you put the W on the side, right? So now the dot product, so you just grab the X for the V and the X for the W, multiply them, so it'll be 1 times 5 plus, so you get the Y for the V, which is -3, and the Y for the W, so it'll be 12, so it'll be -3 times 12 over the magnitude square. So the magnitude will be the square root of the X square of the W and the Y square, but you need to square the magnitude. Now the W is 5i plus 12j All right, so let's work this out. So 5 minus 36 be -31. So the square and the radical will cancel. So you get just 5 squared plus 12 squared will be 169. And then you have 5i plus 12j. And if you want to write it exactly like they did, you would distribute that -31 over 169. You get negative 31 times 5, so it will be 155 over 169. And the I. Now notice that negative, right, hits the positive, so it will be again negative 372 over 169 J. Okay, so well, obviously that's letter A. Now take a look at letter D. They put 13 there. Do you see why? To distract, and they know that people's going to forget about the square. The square root of 5 squared plus 12 squared is 13. Okay. And also, that might be an option. Looks just like A, but instead of having a negative signs, they might have another option that has a plus sign in the middle, because there will be a sign flip. Okay. Yeah. So that's one subtlety. The other subtlety is one of the students in what's going on with this? In my first or second, I think first period, the student asked me, what difference makes if I do project of W onto the V? Well, it's calculated to make sure you know that they're actually very different. Do you see the pattern for the formula? When you have the W on the bottom, right? See that the W is lower, so it goes to the bottom. Now, if the V is lower, the V goes to the bottom. So you're gonna revise the formula so you get the W that goes first in the dot product, dot in the V over the magnitude of V square. You're gonna put the V on the side. So it's all about V's now, right? Except for the first vector. So I don't have to do the calculation, but just to take a look. Do you think that V dot W and W dot V are the same? Are they the same? Because it's just multiplication, right? So you swap them, it's the same. That means these two calculations are the same on the numerator. But do V and W have the same magnitude? No, they have very different magnitudes, right? Not to mention V and W looks very different. So when you calculate that, even if you get the same dot product, but the rest of it is very different. So this will be a different vector. That means you have to be very careful about the order. They might say, find the projection of the W onto the V, okay? Or the projection of V onto the W. So the order matters. Okay. Now, coming back to, let's see what's 20. Oh, anyway. And there'll be questions like I already showed you, right? But I'll come back to number 20. So, so now they realize if I can project a vector V onto a W, so I'm getting a vector that's in the same direction as the W, right? That's the projection of V onto the W, right? And that's known as a component of the V in the direction of a W. And they call it V1. And they will say V1 is parallel to W. But of course, you know, because the V1 is the projection of V onto W, so it has to be in the direction of W. That's why V1 is parallel to W. Okay. Now, they want to find out another component of the V, which is not parallel to W. And all I have to do is take this parallel component out of the V. So the original vector, subtracting the component that is parallel, whatever that's left is perpendicular. And instead of calling it perpendicular, they say orthogonal. The same thing. Okay. But we don't have to do anything extra. Do you see that? It's basically when you get the projection, it works out as the parallel component, right? And you subtract that off from the V, the original V, you get the orthogonal component. And let's do that with the same exact setup that we had yesterday. If you remember that V is 2 minus 5, or 2i minus 5j, W is 1i minus 1j, right? So find out the V1, which is the parallel component. It's as simple as just finding the projection of the V onto the W, right? Up to some work, right? We figure that it's 7/2 I minus 7/2 J. If you don't remember how we did that, watch the recording, you know, either like a couple minutes ago or from yesterday. Now, V2 is the orthogonal component. We have to just subtract V1 from the V. Subtract the parallel component, you get an orthogonal component. And let's do that explicitly. So V is 2i minus 5j. Subtract one of these 7/2 I minus 7/2 j. And the reason why I enclose them in a parentheses is to make sure that I keep track of the signs. So then you lose the parentheses, you get 2i minus 5j minus 7/2 I plus 7/2 j. Because you're removing the parentheses with a preceding negative sign, you will have to flip the sign, right? So now you see the like terms, right, are 2i, negative 7/2 I. So you combine the two like terms, it'll be 2 minus 7/2. That goes together, right, in front of the I. So then you have negative 5 and 7/2 j. So it'll be negative 5 plus 7/2 j. And you work it out. This is negative 3/2 I. And that's also negative 3/2 negative 3/2 j. Okay. Now, if you want to visualize it, you don't have to, but let's just make some sense of what we did. So what does the V look like? V is 2 units to the right, 5 units down, right? So this is V. So what about W? So 1 unit to the right, 1 unit down, right? So it'll be something like this. It's not draw to scale, I just want to make it a bit easier for you to visualize. This is W. Now V1, that's 3.5. Oh, you know what? I think that it's a lot shorter than that. All right, so that's W. V1 is 3.5 units to the right, 3.5 units down, but it needs to be parallel to the W. Okay, do you see that? Now V1 is obviously shorter than the V, since you project the V onto the W, and V1 is the component, or let's say the part of the V that's in the direction of the W, but gets a little bit less in length. But what about V2? You subtract off the component that is parallel to the W, whatever that's left will be perfectly perpendicular to the W. That's all we did. And do you see that? You didn't have to do the kind of a drawing to visualize it, because the math will work out perfectly if you just follow the rule. Okay, and now projection should be easy enough as long as you have the formula down, right? Then subtract that out from the V to get the orthogonal component. That's almost trivial. Okay. And that's what question 22 was asking. But I'm not going to do it, because it's the same thing. All right. You find out a projection, right? You project the V onto W to get the V1, which is a parallel component to the W. And then you subtract that from the V to get V2, right, which is the orthogonal components. And therefore, you see that from the options, A, B, C, they all have the same exact V1. And the V2 is a bit different because they were expecting you make this little, error, or maybe someone else, right? But guess what? You're expecting that the answer better be one of those first 3 letters, right? And it turns out the answer is B. But you, of course, do that. That's one of the question from the final review packet, right? Work it out, make sure that it is the case, right? Not bad at all. Even if the formula for the vector projection is not on the formula sheet, but if you just remember that one, then you'll be fine. Now, word problem. There's always going to be word problems. And this time, it will be word problem about different concepts, and not just always about triangles So in this case, it's about vector. They say in physics, they define something called the work, not the kind of work that you do, it's physical work. Down by the force, it's a dot product between the force vector and the movement vector, which is A to B, right, from A to B. But you know that the dot product has a geometric, definition, right? So it's the magnitude of the force times the magnitude of the movement. Oops. Times the cosine of the angle in between, right? So let's say I have a force that is 2 units long. Then I have a movement vector that's 5 units long. The angle in between is 120 degree. 120 degree. All right, so the work done is magnitude of the force 2, magnitude of the movement 5, cosine of 120 degree. Make sure they're using the degree mode in the calculator, and it's going to work out as -5. Okay, that's it. If they told you the magnitude of the two vectors, the force and movement, and also they tell you the direction in such a way that you can find out the angle in between the two vectors, that's what you do to find out the work. But what if the vectors f and the vector ab are given in their rectangular forms? So the I and j's. Let's take a look at a question like 22. So f is 7i plus 4j, right? Now the movement vector, you kind of have to find it from what they told you. So the point, the object starts from the initial point 9, 4, ends up being at the final point 14, 19. Is there a way you can find out that movement vector AB from the initial to the final, right? So it will be sometimes something in front of the I, right? Some other numbers in front of the J. Oh yeah, Max. Exactly, the order matters a lot, right? So it's 14 minus 9 and 19 minus 4. You subtract the corresponding x and y's, but final minus initial. This works out as 5i plus 15j, right? So now since you have the force vector, let's go ahead and do the dot product to find out the work. So just grab the x's, right? So it'll be 5 times 7 plus the product of the y's will be 4 times 15. Oops. This is 35. That's 60, so you get 95. Okay, that's all. Don't worry about the units. Right. So you haven't learned anything about that part of physics, right? It's feet pound, right? Whatever that is. But that's good enough for you to pick letter D. Well, guess what? Why they have a -95 out there? And they're expecting that our students might swap the points. They didn't realize that it's the final minus initial. But if you do 9 minus 14, 4 minus 19, you're going to get a -95. Yes. So try to find something equivalent in real life situation. So what do we call this vector? Movement, right? So movement starts from a point in a space, right? Ends up being at a different point. How do you measure the movement? Do you add or subtract? You find a distance by subtracting, right? Does it make sense? Now, when do you add? So I move this way, right? I moved like 2 meters. I move in another direction, 3 meters. Then you add them. You want to get a total, right? But to get how much you have moved from point A to point B, you subtract the coordinates of the 2 points. But it has to be the coordinates of the final point minus the coordinates of the initial point to find how much you have moved, right? How much your position has changed, right? Yeah. But I'm glad that you guys realize, since there will be distractions, right? That assume that you might forget about the order of the subtraction, or you might think that you're adding instead of subtracting them, right? Hopefully that you will have time, to alert yourself, because I'm sure that 25 questions, you guys might finish it within the first hour. Okay. Then hopefully you can spend at least another 10-15 minutes, right? Go through the questions to do some sanity check. All right. So I think that should be it. All right. So let me emphasize one more time. So you guys need to review all those questions, all right, in the final review packet, which is available in D2L, except for those 3 questions from 23 to 25, right? Yeah, well, let me go to that screen so you can see it. So 23 to 25, those 3 questions are not needed, but for the remaining 62 questions, go over as many of them as you can. Or I'll say that try them over the weekend. Then if you want, come to me physically in the office next week, or maybe try to meet me over the Zoom. All right, so right, that's all. All right, then keep an eye on the detailed announcements. I'll let you know any updates about the final as soon as I get it. Oh, guys, if you practice with those problems, use the same calculator that you'll be using for the final. You don't have decimals, right? So people are getting the wrong answer from the calculator, because they didn't realize the syntax. They didn't know how to use the syntax correctly, right? Otherwise, you're good to go.